Welcome, students. We're going to start Chapter 2 today, which deals, again, with kind of an introduction to chemistry, but specifically focusing on the two major topics and defining them of chemistry. If you remember from last chapter, we defined the two major topics, and that is matter and energy. So we're going to dive into that in a second here, but we want to start out today with a little bit of chemistry humor. So I want you guys to answer this question. What is HIJK-LMNO? And we'll stop right there. Hopefully you're able to get the answer quickly because it's real easy. It's one of the most simplest substances, and that is the answer. It's H2O. If you didn't get that, that's okay. I'll help you out in class. So like I said, we're dealing with two major topics. The first major topic that we're going to deal with is matter. And we're going to ask the question, well, why does it matter? Because this is in a sense, the central substance in which all the universe is made up of. Everything in the universe is made up of matter. And that's, to a large degree, what we study in chemistry. And one of the problems we're going to run into is if we're studying everything that the universe is made up of, that's a lot to study. So we're going to find ways to classify this, to organize this, to make it a little bit easier throughout the year. So let's start off by kind of defining what is matter. Matter is one of the simplest definitions in science, and that is it's anything that takes up space and has mass. Make sure you understand both of those concepts, that it takes up space and has mass, which the reality is pretty much everything does that. So we're going to need to narrow this down to define this a little bit more. Now, one quick thing, and we'll touch on this more a little bit later. When we're talking about mass and weight are not the same thing. There is a relationship between them. Obviously, anything that has mass will have a weight as well, but weight is simply gravity's pull upon something. And if you went to a different planet, or let's say you went to the moon where the gravity is about 1/6 what it is here on Earth, your weight would change, but your mass would not. Okay, mass is the amount of matter that makes up an object. So understand there is a relationship between the two, but they are not the same. Okay, the way we organize matter is we use physical and chemical properties. We will even do some of this in a lab later this year, is we will test some of the physical and chemical properties of something. Physical properties, and it's very important that you understand the difference between these. I can guarantee you I will ask you this on a test. Physical properties are properties that someone can measure without changing the material. Okay, that's the key idea there. Is there things that can be measured without changing the material? In other words, at the end of the day, it is still whatever that substance is. Okay, we didn't change it. And we'll give some examples of what physical properties are. You guys could probably think of some physical properties. Some of them are really basic. Chemical properties are properties that describe how a material changes into another material. This would often be the idea of a chemical reaction. So as we put two substances together and it changes, it's altered, we're seeing, well, how does that come about? And so that's the difference, is physical properties, we're describing those properties that don't change. Chemical properties are the ones that do change. And that is a key difference there. And so we're looking at those to be able to classify them. Okay, what are some physical properties? Some are even more basic than the ones we're going to list here. Things like color or whatever. Those may be some basic ones, or the texture of something might be a physical property. We're going to deal with some other ones that you'll see listed in your book. One is density, and we will actually have a lab just focusing on density in and of itself and how you measure density. This is kind of an important concept. Density is the mass of an object divided by its volume. The formula, and you may want to write the formula down, it's D for density equals M over V. Okay, mass divided by volume. The mass is usually given in grams, and the volume is usually in milliliters. There are some exceptions to that. We'll do some calculations with density in class. And that basically is you're figuring out how much of a substance can you fit in a given space. Some things are more dense than others. Gases tend to be not dense, less dense. Things that are solids like metals tend to be more dense, and there's some metals that are more dense than others as a result. how malleable it is. And this is usually a property of metals, and since most of the elements on the periodic table are metals, and we'll take a look at that when we get to the periodic table, this is a property of metals that allows them to easily be hammered or rolled into shapes, and some are easily hammered or rolled and some are not. Iron, not so much. Gold, very malleable. And so that's another property that we look at. Ductility, the property of metals that allows them to be drawn into thin wires. Things like copper, it's a little bit easier to do that. Gold, silver can be drawn into wires. Iron, not so much. Titanium, not so much. Okay, another one, conductivity. This is a property that measures the ability of a material to transfer heat or electricity, and this can be anything. This doesn't necessarily have to be metals. And the reality is even it varies within the metals. We usually think of a metal, it will conduct electricity or heat. Some conduct heat or electricity better than others. Others do not. Wood actually is a poor conductor. Wood will not conduct, even though we know wood burns, it doesn't conduct. You can hold one end of a piece of wood, the other end be on fire, and the other end you're holding, and it won't conduct that heat through the wood. So it's not a good conductor. And so those are some of the things that we look at, just to give you an idea. On the other side, there's chemical properties. Combustion, so does something burn, and as it's burning, it's obviously changing into something else. If wood's burning, at the end of the day, it's changed. It's not wood once it's done burning. It's now ash and soot and smoke, and there's energy given off in the flame, so it changed properties as it went on there. Corrosion is another example. And this could be acidic corrosion if it comes into contact with an acid. It could be corrosion where you have like water and metal where it begins to corrode over time. So those, they basically, you end up with a chemical reaction there and you end up changing the substance. So those are some things that we do to classify matter. Now, once we've done those tests and we begin to organize them into different sections, what are the classifications? So that's what we want to look at. And you will want to understand the difference between these two major categories. The first category is pure substances, and I'll let you know the other major category is mixtures, and we'll get to that in a little bit. But pure substances are materials made up of only one kind of particle, and there's kind of subcategories to all of these. So there's several different things that can be pure substances. So let's look at some of those. One is an element. Okay, and this is a pure substance that cannot be broken down into a simpler substance by ordinary chemical means. And this is kind of what makes up, we have the periodic table of elements, that's what makes up the universe. In other words, you can't get any simpler than oxygen. Oxygen is not made up of a number of different other things. Oxygen is made up of oxygen. That's it. It's as simple as it gets. It can't be broken down any simpler than that. Now, you can have a smallest particle, and we'll talk about what that smallest particle is. It's called an atom, and I think you have that on your definition sheet. So there's a smallest particle of an element, and there's a smallest particle of a compound as well. But those are simple substances. A compound are materials made up of atoms from two or more different elements that have been chemically bonded together, and that is key to understand. That they've been chemically bonded together. So they are acting as one thing. It's a marriage in a sense. So they're acting as one. So you take water, H2O, we know it's made of hydrogen, 2 hydrogens, and 1 oxygen. So it's not an element. It has 2 elements, and sometimes compounds have even more than that. So it has 2 elements, but they're bonded together, and therefore they act as one. And just to use an example, if you think about it, hydrogen, very explosive gas. Oxygen is always required in the presence of fire, so you have 2 things that are highly combustible, and you put them together, you would expect to get a gas that's highly combustible, but instead the properties change when they're chemically bonded together, and you get water, something we use to put out fire, and it reacts very differently. Why? Because it has new physical and chemical properties. It acts as one. The hydrogen doesn't keep its properties and the oxygen doesn't keep its properties. They now change into something else entirely. Okay, so compounds are materials that are chemically bonded together. Now, the other side to that is you have pure substances, which are elements and compounds. And again, the smallest particle of an element is an atom. Smallest particle of a compound is a molecule. Okay. Now we go over to mixtures, and the difference here is a mixture is a physical combination of two or more substances. And you notice I have here, it can be separated. That's the key. Okay, mixtures can be separated. You know, and it may be through a number of different processes. We'll do some of those processes in labs, like filtration, distillation is another one. You can use a magnet in some cases to separate mixtures, but they can be separated. And there's a couple categories of mixtures. And the first is heterogeneous mixtures, and these are mixtures that have distinct regions. In other words, you can see where one starts and the other stops. Good example of this, if you mix iron filings in with, let's say, sand or something like that, you can see where the iron filings are, even if they're all mixed together, because they're kind of black, and the sand is, you know, more brownish. And so you can see the difference between them, even though they're all mixed together. There's a visible distinction. A homogeneous mixture, and homo there meaning the same, are mixtures that do not show any distinct regions. So an example of this would be like the air, okay, around us. Even though the air is made of nitrogen and oxygen and a few other gases as well, you know, where is the oxygen and where is the nitrogen? It's all mixed together. Okay, you can't see. Salt water is another good example. The salt's all mixed in with the water. You can't see, oh, there's salt, there's water. It's all mixed in together. That would be a homogeneous mixture. All right, what about the formulas? Each element has its own unique chemical symbol. And this is going to be important as we get introduced to the periodic table. And there's some basic rules for chemical symbols. So as you look on the periodic table and you see all these elements and they have these different symbols on there, how do you write them? Okay, well, the first letter in the symbol you'll notice is always capitalized. That's the first basic rule. And so anytime you write it, you will have to capitalize that first letter. The second rule is kind of the opposite. The second letter, if the symbol has one, not all of them have two letters, but if it does have a second letter, the second letter is always lowercase. And that is important, and I'll show you why that's important in a minute here. Okay, what are some other things you're going to see with formulas? When you start putting elements together and you form a compound, so we have something that's bonded together, you're going to use a subscript written after the chemical symbol, and I'll show you an example of this in a minute here, to show how many atoms are in a particular molecule. So if you have 2, you're going to have a subscript of 2, or if you have 3, subscript of 3, like in the formula H2O, that 2 there tells us there's 2 hydrogens. A coefficient, so you may remember coefficients from algebra, that is written in front of the entire molecule to show the total number of molecules there are. And this is something that we won't deal with to as large or to as great an extent in this semester. Next semester, it will become more important, the coefficients and what they tell us. To determine how many atoms there are in a molecule of a particular element, you simply multiply the subscript by the coefficient. I'll show you how that works here in a second. This is something I will have you do on the test. So let's take a look at some examples here. Here's an example of a compound. We've taken 2 elements, iron, which is Fe, and O, the oxygen there, and we have subscripts for them. The 2 goes with the iron, and the 3 goes with the oxygen there. And so what that tells us is, well, this particular compound has 2 iron atoms and 3 oxygen atoms. Now, if we put a coefficient in front, okay, and you notice that 5 there in front, that 5 applies to the whole compound. And so now if I'm going to figure out, well, how many iron atoms are there, I'm going to multiply that 5 by the subscript. And so you notice I end up there with iron has 10 atoms. Oxygen has 15 atoms, so there's a total of 25 atoms in the entire compound. 10 of them are iron and 15 are oxygen. Okay, so that would be something that would be worth understanding, what all those numbers are there for, and what do they tell us? The 5 tells us how many molecules there are. Okay, last thing I wanted to point out, why do we capitalize and why do we not capitalize? Okay, you'll notice here we have 2 things, both with a C and an O. But the first one has a capital C, capital O. Well, what does that tell us? It tells us that we have carbon bonded to oxygen to form the compound called carbon monoxide, a poisonous gas that comes out your car. The other one, capital C, little o, follows the rules, and that's the element cobalt. So Things like that, if you're not careful, you can get them mixed up. That's all we have for today.